Hello, yellow stickers. This is your first problem. So it says that gravel, which is just a type of dirt, is falling on a conical pile. That tells us that the pile of sand looks a little bit like a cone. And we have a nice diagram for you that says gravel is falling on the conical pile at a rate of 10 cubic feet per minute. So that 10 cubic feet per minute, the fact that it has something per minute should tell you that this is a rate with respect to time. What is changing here? That feet cubed should give you a clue. What measurement is cubic? Volume. So we have the volume of the cone is changing at a rate of 10 cubic feet per minute. At all times, the radius of the cone is twice the height of the cone. That gives us a nice relationship for radius and height. At all times, the radius of the cone is equal to twice the height of the cone. Find the rate of change of the height. So that is dh dt. We want this when the radius of the pile is 6 feet. And then, of course, put your answer into a sentence. This is what we want. All right, well, we have the derivative of volume, so we'll probably want to use the volume formula of a cone, which is 1/3 pi r squared times height. We have two variables over here, one over here. Everything is changing when time is changing. So this is going to get messy with product rule if we keep both r and h in the equation. So what we're going to want to hopefully do is use this nice relationship to substitute in and get just one variable. Which variable should we have left over? We want dh dt, so let's keep the h's in there. And instead of having r squared, let's write 2h. So v is equal to 1/3 pi 2h squared times h. Let's rewrite this. V is equal to 1/3 pi 4 times h squared times h, that's h cubed. And now we can start taking derivatives again. dv dt with respect to time, as everything is changing with respect to time. We have our constant multiple here times derivative of h3 h squared. H is changing with respect to time. Take its derivative as well. Now is time to start plugging in. What do we know? We've implicitly differentiated. Now is the time to plug in what we know. We know dv dt is 10. Do we know h? Let's look up here. No, we know that r must equal 6 feet, and we know this. So if r is equal to 6, that must be twice the height, then h must be what? 3. Plug that in here and continue solving on your way. If you have further questions, please talk to me by writing in the Google form, and talk to me when I get back on Monday. Or I won't see you on Monday, so Wednesday. Goodbye.